Good afternoon, everybody. It's a pleasure for me to be here with you today, and I thank the organizer for giving me this opportunity. The objective of my presentation will be to give you an idea what the watch community, the traditional watch community, and more specifically the Swiss traditional watch community, developed over the decade as set of tests and set of standards in order to ensure the reliability of the product. So this will be the structure of the presentation. I briefly introduce Laboratoire Dubois, then look at what is common between traditional watch and what is more similar is any wearable on the wrist. Then the core part of the presentation will be the traditional watch test. I will touch compliance issues as well. And finally, I will compare a couple of standards which do exist in both watch industry and the electronic community, and then draw some conclusions. Okay, Laboratoire Dubois is a privately owned Swiss company located in La Chaux-de-Fonds. You know already it, and created about 40 years ago. And what is, let's say, focusing our job since more than 3 decades is watch reliability. And as an introduction, I was thinking it could be good to show you a short video made by one of our customers in our lab, and he is using this as communication purposes to show what he is doing to ensure this reliability. What is about our lab? So we are organized in different business units, and maybe the most interesting point here on this slide is that we are very active on the watch industry standard. In fact, there are 2 types of watch industry standard. The Swiss one, the Swiss watch industry standard, which is called NIHS, and the ISO TC 1114, Patrick told already. So if you need further info to our lab, go to our website. So what may be in common between traditional watches and wrist wearable? Okay, you have here a couple of informations. In fact, they face the same environment. On the left, you have a smartwatch and some sportman which is desalterating himself. And on the left, you have very well-known sportman or sprintman, which the second one is Johan Blake, is wearing a very high-end, complex mechanical Swiss watch. And there are, like that, ambassadors, as was said this morning, which are being used to show that the mechanical traditional watch is withstanding a lot of things. And this is the case here. For example, even if Johan Blake can wear this kind of product while he's running, and this type of product here is around $500,000 Swiss franc. Just to give you an idea. So the same environment means that the customer should expect for both very similar feature. I tried to summarize it like that. Function over time. We don't like, and Mr. Ebrahimi don't like when his smart watches doesn't work anymore. So we don't like if the function is not anymore there. We don't like if after center time it's look very badly. If the design is so, we may have some water resistance. We will come to this point later on. And finally, should be safe and should comply to legislations. So here there is a common point between traditional watches and wrist wearable. But this is what can be found on the internet, for example. And one main topic that you can find is strap failures. Here you have a different kind of strap failures. You have failure, a complete failure, a broke. You have micro cracks on the left, which is due to the aging of the polymer. This is a rubber-like material. You have total destruction on the top here, right top. And you have a permanent deformation, which is maybe not a critical issue, but nevertheless is not something very nice.
Traditional watch, you mean a mechanical watch?
Yeah. Traditional watch mean mostly mechanical watch, but there are also electronic watch, which are, let's say, covered by this standard. This is one thing, but then you have other things. You have skin irritation issues. And this happened really, even burning in some case. But the traditional watch community is facing as well this similar problem and is acting to avoid it. So this is a common requirement. And here I go now to the test and standard. Okay, usually the watch community is separating different components of the watches. Typically, watch head or movement, the case, the bezel, if any, the wristlet, which can be of different material, the clasp, and dial and hand. We will not touch here dial and hand because it's not comparative with smart devices. I tried to summarize here some standard, let's say the most important maybe standard for the watch industry. The first one is a reliability standard, which is also only existing on the Swiss level. Water resistant, there are two ISO standards, one for normal water resistant watches, and the other one much more stringent for diver watches. Then there is a third standard. The first one was you will see it's related to small indirect shocks, while the third one is an accidental shock. It's exactly what you saw at the end of the small video, when we have this head which has been impacted quite deeply, and then here you have to imagine that mechanical watches, they have a very, very thin oscillator system, and this oscillator system are very much disturbed by such an impact. Magnetic resistant watches as well, ISO standard, and then there is a purely mechanical watch dedicated standard, which is an accuracy standard, which is the standard which define if a chronometer, if a chronograph, sorry, is a chronometer or not. There are differences between these two definitions. For watch cases and accessory, you have climatic test, you have wear test, and you have a specific ISO standard for the watch glasses as well. If we come back to this last view of the small video, this ISO standard, which was reviewed recently, consists of different set of tests. A first set of tests are 3 impacts on the watch head. You see the arrow. One impact is at 9 o'clock. The other is on the glass. And the third one is directly on the crown. This was added during the revision. And moreover, if the watch is said water resistant, this feature should not be degraded by this third set of tests. And the second set of tests is not the watch head alone, but it is with the wrist. And you see on the left just a lady putting it on a plate. The plate will open very rapidly, and you have a free fall in 2 different positions. And if the watch complies to all these requirements, then it can be marked as shock-resistant watch. Or on the bottom, for example. It's what we call, let's say, a label standard, okay? Because if the requirement, you can communicate to the customer, it's shock-resistant. Magnetic resistant watches is an ISO standard, is currently being revised because, for example, what is existing in this standard today is exposing the watch to a DC field of this intensity, and this is not anymore what our environment is, because over the last decade, the magnetic field increased very much, and this is just currently under revision. And of course, after exposing to a field, we will measure the residual effect on the movement. Here, again, this is a kind of, how to say, label standard, because you will find on normal watches magnetic resistant. Okay. For the wristlet, for example, for laser wristlet, on the left, you have a synthetic sweat test, where you soak with synthetic sweat a kind of felt, and you put the laser wristlet on it, you put on the oven for some time, and then you see what happens. And in that case, for example, you have a transfer of color from the strap to the felt, which may simulate a white shirt, for example. So this is not maybe very nice to have this type of situation. In the middle, most for watch cases in steel, you have a traditional salt spray test to see if some problems may occur of rusting, even of stainless steel, because stainless steel may be locally activated because of some small creaks or some small defect. And on the right, you have a laser strap before and after UV test. Okay, and this is not that much. Well, this is an extreme case, but this is about 30-hour test, and you have an incredible discoloration. About wear, mechanical wear of the surface, this standard, which is quite new, is describing different type of tests to assess the wear behavior. And I just put here 3 of them. The first one on the left is vibration wear. We have ceramic chips, and we put you can see the watches here illustrating there. And all this is vibrating, and you have a kind of wear, and then you will see if after this accelerated aging, if you want, how look the piece. In the middle, you use fine silica powder, and you have a kind of what we call turbula system, and we mix it with a piece, and then we see fine scratches on the surface, which are representing the scratches that may occur in the real life. And at the end, a free-fall test of the watch or of the element in a ceramic chips bed, and give at the end this pattern there, the pattern on the metallic piece of wristlet there. This standard was developed trying to match between return from the market of different components and test which will do the same pattern when we do on the lab. For glasses, there is an ISO standard saying how to assess the defect of the glasses, how to measure the hardness, and how to measure the failure or the cracking energy. And you have on the right here the device, how to measure it. You have a steel ball, which is magnetically stick to the top there, and there is the two distance is 8, and we increase incrementally the 8 until we got the failure. These were the main, let's say, standard. There are a lot of other tests. Some are proprietary, some are just, everyone is using it, but they are not standardized. One of the tests that we have in our lab, it's what you heard in the video. It's a chronofiable reliability test. This is a test which was developed by a protocol, let's say, which was developed by the Swiss community, watch community, more than 30 years ago, by putting thousands of watches on the market, on the wrist, and by testing thousands of watches as well. At that time, the watch community was really working, all the brands were working almost together to find out the best way to assess the reliability. And this is, in this case, in fact, this test, which have a duration of 3 weeks, it's good to reflect what happened on 6 months wearing for the movement. This is a test only for the movement. We are able to do any kind of shock tests. This is just, and we do it, by the way, not only for the watches, but as well for sensor, for MEMS, and of course for smartwatches as well. Then everything which is moving, or the customer can move on the watch, we test it. That means we move, and we move many times. We do a lot of cycle, and we see if the load, or the force, sorry, or the torque is unchanged or change a lot over the cycle. The rotating bezel, for instance, the stem, push button, all these things we do up to thousands of cycles and see if the different mechanical conditions remain stable or not. For wristlet and clasp, you have here the short video showing random movement on metallic wristlet. This test is very interesting in order to assess the potential unscrewing on extension screw. You know, on both sides of the wristlet, you have extension links which can be taken out or added according to the size. And this test, it's about 10,000 cycles like that, is able to see if you will have some issue with unscrewing. Then you have a pull twist test, which is reflected on the left there. So it's a twisting test together combined with tensile test. And this is important for the wristlet, but also for the attachment. And I have a very short extract of a video, which is not our video, but we were able to take just the extract, which was done in our lab. So it will be quite rapidly, but you will see how it's work. And if we can add sweat and temperature and wrap everything and let it for some time. Clasp aging as well. These are typical for the traditional mechanical watches or even electronical watches. And you have closing forces and opening forces, and we check if these forces are not changing too much over time. As a test, here another extract of this video. It's leather strap. So we do wear test with a kind of felt, a square-shaped felt, and we measure, or we look at how the leather is wearing, and we look at as well at the color of the small felt if you have some discoloration. We do it dry and we do it wet, and then you'll see at the end it's very rapidly. Then in the wet case here we have a color transfer. Here. And the strength is done by doing a tensile test, just like that. There is one standard in the watch industry for diver watches which require to reach 200 Newton for 1 minute. But a lot of people are testing on a routine basis for all development, all new products, this type of issues. And for rubber-like or rubber-type strap, ozone is an issue because you can have a depolymerization with ozone. And there is a test which is not a watch community ISO standard, but in which we take the rubber strap, you put it on strain, and you put it in the environment with a given concentration of ozone, and you may end up with in an extreme case, with this. So this gives you an idea of the tests that are routinely done in the watch community, in the traditional watch community. Maybe at that point it's important to underline that these tests are not, let's say, reserved for very high-end watches. But even all the market segment are using part or totally this test to assess the reliability. Then there is another subject which may be common between the two industries: compliance issues. First of all, within the traditional watches, we already have a difference between mechanical and electronic watches. If we take Europe, because we're in Europe, mechanical watches, they shall only comply with REACH regulation. REACH is a European regulation for all chemical issues. But for quartz watches, they also shall comply with ROHS regulation and REACH. Of course, Wearable shall comply to both. If we talk about REACH, the restrictions are not that complicated for metallic item. You just have to avoid higher content of lead and chromium, and you have a specific test for nickel release. There are maybe 25 to 30% of women and maybe 10% of men which are said to be allergic to nickel. And there is a European standard which describes exactly how to do this release test and measure. It takes about 1 week to do it. And there is a limitation in the legislation, and this is to be controlled for every part which is in contact with the skin. But if we talk about other material, leather, rubber, textile, and so on, the situation is very much more complex. A lot of organic molecules are restricted. I take just a couple of examples here, but there is a list of more than 30 molecules which are restricted by REACH legislation in Europe. Chromium-6 in leather, for example. Chromium salt are used for preparing leather. And they are used as chromium-3, which are no problem with chromium-3. But over the time and over the aging, chromium-3 may change and shift to chromium-6, which is said to be carcinogenic, for example. So this is an issue. And last year in May, REACH decided to limit the amount of chromium-6 in any item up to 3 milligrams per kilo. Okay. If you take product for children, for example, they face even higher requirement, because if you market something which is intended to be given to children, you have a toy standard which is very stringent about the restrictions. And finally, you have the waste management standard or requirement, which said that for electric equipment and any kind of electronic watch, you cannot throw it away where you want. You have to recycle it in a way. But if you take a pure mechanical watch, you may have to take, you can do it without, we are not restricted by this. So I will go briefly to these two standards. I try to check and compare the watch standard about mechanical shocks and an IEC standard. And surprisingly, I found very similar things. That means that there are models how to modelize the impact, the shocks, and the half-side model seems to be a common model. And the Swiss watch industry decided to set 3 levels of peak acceleration, 2500 and 500 G. And by the way, we find in the IEC standard exactly the same parameter with quite some small difference in the other related parameter, but the shape and the tolerances between the mean value, plus minus 20%, are exactly the same. This would mean that electronical community may be able to check traditional watches with their standard, and to some extent, the Swiss watch community could also check, according to his standard, wearable. If I take the water resistance standard, the watch standard comprises a lot of different tests. The main important maybe is water overpressure. You have here the device, you put the watch head, you put the overpressure, which is minimum 2 bars, but on an average 3 bars. That means 20 or 30 meter depth. What is interesting as well here is that we have a low depth immersion while trying to apply load on the crown or on the push button in order to increase the risk to have water penetration. You have also difference in temperature. You have immersion in different temperature. And this standard as well is also called label standard. If the watch complies all these requirements, it can be marked water resistant. And I tried to find some similarity in the IEC standard. I found this one with the IP code. They propose 8 requirement levels for water resistant. We heard this morning splashing resistant, for instance. So what we can see is that only 8+ level would offer similar severity as the watch standard. So conclusion, a first set of conclusion that, in fact, the customer expectation besides the function are the same for the traditional watches and the wearable. And second conclusion, to some quite high extent, the legislation are overlapping. Then we see, because we are coming from different industry, from different degree of maturities, that the same requirements are not giving same standard at the end. And finally, maybe the wearable community may take advantage of what is existing in the traditional watch industry, especially, maybe not for the device totally, but especially for the strap, for instance, to ensure better reliability. OK, I'm done. We have a nice logo here because our customers sometimes, they saw us as watch destroyer, you know. And we try to destroy them always in the same way. Thank you, for your attention.